All right, let's pretend you're me. Let's pretend that you like to use the STM32 Blue Pill, and you're going to ignore the fact that Raspberry Pi Pico is out, because you can't buy them right now anyway. And you want to see if you're being held back by slow Arduino code. Let's dig in and find out. And maybe we'll figure out a way to get this thing faster. Okay, so how are we going to test this? Well, I'll show you. We're using Platform IO, which is my favorite IDE. And if you're curious about it, ask me. Maybe I'll make another video. I'm already making another video, hint, hint. And maybe a podcast about this, because I like Platform IO so much. Within, what is it? VS Code, which is what? Visual Studio Code, is that it? Yeah, Visual Studio Code. And it's not the same thing as Visual Studio, so don't get confused. Anyway, we'll include the Arduino header. We have a setup function and a loop function. Our setup function is just a pin mode declaring PC13 as an output. PC13 is a pin, kind of like pin 13 on an Arduino Uno or something. And we're going to go ahead and toggle that LED once. We turn it off and then turn it back on. And I do that just to make sure the damn thing ain't dead. You know, it's good for me because everything's always dead. And then in the loop here, we have turn the pin 13 on, turn it off. That's it. And it's just going to go, there's nothing slowing it down, no delays, nothing else in the way. So this gives us an idea of how fast this microcontroller can run. Let's test it. Okay, and here's the results from the scope. We can see, if you look at the bottom right corner, frequency, 462 kilohertz. That's not slow, but it isn't really, fast either. What do I think of that? I don't know. Let's keep working. Okay, so there's this new function called, well, it's not that new anymore. It was new to me, DigitalWrite Fast, by a guy named Nixon Yap. Good name. And what he claims, right here, is that DigitalWrite on an Arduino Uno takes 6,280 nanoseconds. Well, here on the old TI-36, that says 160 kilohertz. It's pretty damn slow. Of course, we're only at like 3 times that speed, which is not as fast as I think we should be. But he thinks, or he claims, you can knock it down, DigitalWrite down to 125 nanoseconds, which the TI-36 says 8 megahertz. That's way faster than us. And an Uno is only 16 megahertz. The Blue Pill here should be closer to 72 megahertz. 5 or 6 times, well, 4 times faster than that, give or take. 3, 4. Yeah, man, I can't do my math in my head anymore. Too old for this. Okay, so let's implement it. Well, here's the cool part. It already is. It's part of the STM32 Arduino thingy. So check this out. We just add fast at the end. I want to make it clear that the declarations, the setup, pin mode, we'll just leave it the same, PC13. But check this out. We get a squiggly. We get an error right here on PC13. Well, what in blue blazes is this rubbish? Well, I'll show you. What we're going to do is put an underscore in between them, the stupid letters and the stupid number. And then all our problems go away. And we can compile. Let's see what we get. Okay, and so here's our results from DigitalWrite Fast on the STM32 Blue Pill. I find this interesting. We're getting these tiny little spikes. The duty cycle on this thing is near 0. Duty cycle is the percentage of time on versus percentage of time off. And I would have liked to seen 50%, half on, half off, kind of like we saw previously. So that's kind of a red flag. And what's going on here? Frequency, 1.04 megahertz. Well, that's certainly faster than what we had before, which was around, what, 450 or so. So we're about twice as fast, but that's it? Only twice as fast? Let's keep digging. All right, if this doesn't work, nothing will. We have the same code as before in terms of setup, but in the loop, we got the monster Big Daddy. We're using what's called bitwise functions or bitwise logical operators. For you people that are new to this, when I first saw this kind of stuff, I went, what the frick is this? It's actually really simple stuff. It's kind of beyond the scope of this video. The short version is, this is just a 1 with 13 zeros behind it. We've shifted it over 1. Let's see, let me do it quick. we'll do a super quick tutorial. This is one with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we are ORing it with whatever's already there, which, it's a long story short, it means we're setting 1 at position 13. That's all you really need to know. And then this one's even nastier. We'll skip it. If you don't know it, don't worry about it. So we're using bitwise functions. When you use bitwise, this is about as deep as it goes. With we're using real C right here. This is not Arduino stuff. This is straight to the core. Only way to go faster than this, as far as I know, is assembly. So let's see what happens here. All right, boys and girls, I'm excited about this one. Let's see what we get. What? 1.22 megahertz? That's it? This is kind of frustrating. I thought we'd be way faster than this. We need to know more. And here's that part when you're not sure what the hell's going on. You're very confused. You start blaming the hardware. Although, is it user error? There's not much user error to make in this particular case. All we're doing is toggling a pin. So, and because we're in the Arduino environment, we're isolated from all those nasty goodies of clock sources and all the other crap you get with STM32 IDE Cube. So the question is, do we want to go down the rabbit hole and solve this one? It's worth noting that our spikes are better. We have these, let me transform. We have our duty cycle is still not 50%. This bothers me. Now, I am very paranoid right now. One, I don't want to go down the rabbit hole of STM32 IDE Cube, and because there's no end. It'll take me 3 years, unless I get it right first try, of course. But also, I'm wondering, is my do I have just a bad chip? Maybe. This is why I'm actually really excited about the Raspberry Pi Pico. Because at least I can get something where I can always blame me and not just the chip. Alright, so I found a clue. I thought I was stumped. I was stumped. Alright, so this is on the Teensy forum, or a Teensy forum, those weirdos. This guy says it's not a problem with the Teensy speed. Sounds familiar with our situation. It's that weird Arduino environment. Now here's the thing. We're not in the Arduino environment, but we are. We're using Arduino stuff for all this. After each run through the loop, it does thousands of other things, like checking the serial ports for incoming bytes to trigger serial events and so on. To get around this handbrake, you should write your own loop inside the loop so that the outer loop is never executed. So they basically have the loop like we have right here. Oh, I already did it. And then they added a while loop around it. So basically the loop runs and you never actually run whatever this stuff is after the loop. So in other words, Arduino sticks a whole bunch of bullshit goes here. That's what's going on. But bullshit goes here never gets ran because only our little loop now runs. Now I'm not sure what downsides that has for the universe. We'll find out with my big synth project here in about 10 minutes. But let's see what happens when we run this dude. Dun, da, da, da. And here. Wait, that's right. Bam! Look at this. 3.64 megahertz. Now, is 3.64 megahertz as fast as I wanted? No. I wanted 72 megahertz, but I wasn't going to get 72. And we're still in the Arduino land, so I think anything over 3.6 megahertz is acceptable. So I think that's a pretty fast switcheroo there. I think the lesson here is just to go ahead and bit bang. And I mentioned this before on the Electron Injection podcast. Arduino always gives you the option to run the real stuff, and you have to. I've been lazy. I've never actually used the real stuff on the STM32 Blue Pill. I've done it on microcontrollers that are programmed in C, but never on the Blue Pill. So anyway, just taking the time. If you don't understand how these operators work, yell at me. I'll make some videos. They're not hard. They look really stupid because they're shortcuts. But I can explain it to you in about 5 minutes, and it'll save your life. So, I mean, or you could just, I'm sure there's 100 other videos that are better than mine, but use mine anyway. So, if you need help, yell at me. I'm around. If you got any questions, comments, whatever, leave them. Subscribe, don't subscribe, whatever. I do Patreon, do all that crap now. Keep an eye out for the podcast. I'm wanting to push that. I got hopes for it. I don't really know why, but all those links are below. So everybody, thank you. Out. Whoa, whoa, whoa! I just thought of something. Check this out. All right, I have got 12 megahertz off of this scope. It doesn't look pretty, but this actually is a square wave. It just doesn't have time to be square because of all the capacitance on my probes in real life or whatever. But what we do have is symmetry in regard to duty cycle, meaning it's on about the same amount of time as it's off. Remember that bothered me earlier? Well, we solved the problem. How did I do it? Well, find out next week. Maybe subscribe and you'll know. Just kidding, I'm not doing that crap. All right, I'll show you what I did. I found a dude who recommended that was the thing we had on the last step of the video, I guess, was add the while loop. Well, I was using the bitwise logical operators, you know, these things right here that look like, if you're not used to them, they look like, you know, Klingon language or whatever. Those should be as fast as it gets, by the way, as far as I know. Again, obviously I'm wrong because I turned off the bitwise operators and I just used DigitalWrite fast. So the lesson here is to use DigitalWrite fast with a while one condition, so you know avoid the bullshit goes here at the bottom. Now, I don't know if you can do that with Arduino code. I bet you can in the Arduino IDE. I guess there's nothing stopping you from making a while loop. I don't know the downsides to this. I'll probably talk about it in the upcoming podcast because I'm about to find out in about 3 seconds. But if you're not sure how this while loop, what negative effects happen in a real complicated system like my synthesizer, then ask me about it, and maybe I'll tell you. Okay, quick recap. What did we learn? 1, use the DigitalWrite fast approach, and make sure that you change PC13 to PC_13, and obviously that applies to PA12 and whatever other pins we have. The other big takeaway was the Arduino packs a bunch of crap on at the bottom. They don't show you that. They kind of should, maybe. I guess, well, maybe not. You know, that's up for debate. But by having a while loop inside our loop, where all of our actual code goes in the while loop, then we don't ever run that extra junk. Now, is that extra junk necessary? I don't know. You have to tune in next week, or maybe tune into the Electron Injection podcast. It's probably a better one, but ask me about it. I'm getting ready to test it right now, so I'll know all about it. All right, guys, over and out.